How's it going, y'all? These are going to be our 3.3 notes over isosceles and equilateral triangles. Most of y'all probably understand this and know some of these facts, but we're going to explain them here and go a little bit more in depth and obviously see some more complex problems as we work through these problems that involve isosceles and equilateral triangles. So first off, isosceles triangles. These are triangles that have two congruent sides, meaning these side lengths are equal to each other. So the distance from A to B is equal to the distance from B to C. Those two sides that are congruent, those are called legs. Excuse me. The angle where the legs intersect is called the vertex angle. The side opposite of the vertex angle is called the base. So just to clarify, we have our legs. We have our vertex angle. That's going to be this angle up here, angle 1. We have our side opposite, so that's going to be our base. I guess we could certainly label these things. This is our base. These are our legs. Not necessarily the hash marks, the actual segments themselves. This is our vertex angle. All right, and the angles along the base are the base angles. All right, base angles. That would be angle 2 and angle 3. So let's talk about the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite of those sides are congruent. So if you look back at the graphic that we were just looking at, if the distance from A to B, or the segment AB, so if AB is congruent to BC, then they're opposite angles. So we're talking about angle 2 and angle 3. Those are going to be equal. And this has a converse, which means it goes the other direction as well. If you find out that those angles are equal to each other, then you can conclude that the side lengths are equal to each other. All right, so how can we apply that? Let's take a look. I've got problems like these. If I know that this is an isosceles triangle, meaning these two sides are the same, that's what these two hash marks mean, then that means these two angles are going to be the same. So I know that if angle L is 68, then angle J is going to be 68 as well. And I know that if I have two 68-degree angles, and the interior angles of a triangle are 180, then I can do 180 minus 68 minus 68 again, and I am going to get whatever angle K is. So I open my calculator here, and that's 44. This is an interesting one. I have an isosceles triangle here. Again, I know this because of my two congruent sides. And then I have the vertex angle is 106. Now, these two are going to be equal to each other, meaning that I could say that this is like angle X, and this would also be angle X. So X plus 106 is going to equal 180. So 2x plus 106 is going to equal 180, which means that those two angles combined are going to be 180 minus 106, which is 74. So those two angles combined are going to equal 74. So each one of them individually, because again, they got to be the same thing. So 106 plus 74 is going to equal 180. Well, what is that 74 going to be divided into? We're going to divide that by 2. So x is equal to 37. So both of these are going to be 37 degrees. And you can check it, right? 37 plus 37, whoops. 37 plus 37 plus 106 equals 180. All right, here's some more algebraic type problems. And my knowledge of isosceles triangles is going to help this, is going to help me solve these. So for example, if these two segments are equal, then these two angles have to be equal. So I can just set up an equation, 4x plus 7 is equal to 9x minus 33. Because if I have two congruent sides, the angles opposite of those congruent sides are also going to be congruent. So this angle is congruent to this one. Set them equal to each other and solve. We're going to end up with 5x because I'm going to subtract 4x from both sides. And I'm going to add 33. So I've got 5x equals 40, which means that x equals 8. Let's take a look at the other one. All right, on this one, we're using the converse of the isosceles triangle theorem. If I have two congruent angles, then I know that these two sides are going to be congruent. Likewise, up here, if I have two congruent sides, I know that these two angles are going to be congruent. So these two sides are congruent, which means those two expressions can be set equal to each other. 15x plus 7 is going to be equal to 23x minus 17. And we just go through and solve these like we did the last one. So I can subtract 15x from both sides to get my variables together. I can add 17 to both sides to get my constants together. And that is going to give me, yikes, 24 equals 8x, which means that x is equal to 3. And that's all it wanted, was me to find the value of each variable. And there you go. So both of those were found by just setting those expressions equal to each other. Because in an isosceles triangle, these two angles are equal to each other, and these two sides are equal to each other. All right, moving on. Equilateral triangles. All right, y'all, if you have a triangle that's equilateral, it is also equiangular. If you have a triangle that is equiangular, it is also equilateral. I can see that I made a typo in my notes here. This is supposed to say if angle A is equal to the measure of angle B is equal to the measure of angle C, meaning all of these angles are congruent, then, so all the angles are congruent, then all of your segments are going to be equal to each other as well. The distance from A to B is going to be equal to the distance from B to C. Is going to be equal to the distance from C to A. So if all of these angles are congruent, then all of these sides are congruent as well. So we could write them as the distances. So remember, if you don't put a line over the two letters there, that's considered a distance. So this is the distance from A to B, whereas if I had a line over it, that would be the literal segment AB. So we're going to just use distances. These distances are all equal to each other. And then there's a converse to this. If all the distances are equal to each other, then the angles are going to be equal to each other as well. So the measure of angle A is equal to the measure of angle B is equal to the measure of angle C. So the main thing here, all equilateral triangles are equiangular. All equiangular triangles are equilateral. So whenever I'm looking at this first example here, if I know that these also, spoiler alert, if all the angles are going to be the same and they equal 180, that means you've got x plus x plus x equals 180. You divide 180 by 3, it's going to be 60. Every equilateral triangle, not only is it equiangular, their angles are always going to be 60 degrees. So whenever you're looking for the angles, the answer is just always going to be 60. So I could skip ahead to this one right here and just be like 60, 60, 60. On this one, my missing side lengths are all going to be the same. So I know that this is 9 and this is 9. So AC is 9, BC is 9. And all my angles are going to be the same. So measure of angle C is also 60 degrees. I'm not sure we were supposed to assume that this is equilateral. I think that what I was probably supposed to do on this one was say, all right, this is 180 minus 60 minus 60 again. That, of course, gives me 60. Now that I know that this is 60 degrees, then I can conclude that this is equiangular, therefore it's equilateral. I think that's kind of the process that I was supposed to fall into. But as soon as I saw two 60-degree angles, I knew that this was going to be 60 degrees as well. And that makes this equilateral and equiangular. This one is equiangular, and I think this is probably where I'm supposed to figure out that all angles are going to be 60 degrees, because I have three angles that are exactly the same. So 3x is equal to 180. And whenever I divide both sides by 3, I get that x is equal to 60. So all of these angles are going to be equal to the exact same thing. All right, one more problem here. If PQR is an equilateral triangle, solve for x and y. Now, finding x is actually going to be pretty easy here because we've already talked about how the angles, each individual angle of an equilateral triangle is 60. So I can actually just go straight into 7x minus 3 equals 60, which means that 7x is equal to 63, which means that x is equal to 9. So it's as easy as that to figure out x. And again, that's kind of using information from this problem right here, telling me that no matter what, an equilateral triangle, which it's telling us this is an equilateral triangle is going to have three 60-degree angles. So this angle down here is 60 degrees. Set it up. You can kind of see my math here. I added 3 to both sides. Then I divided by 7 to get x is equal to 9. Finally, I need to find y also, and this shouldn't be too hard. On an equilateral triangle, any of these can be set equal to each other. Doesn't really matter which one you choose. I'm going to choose 11y minus 23 is equal to 9y plus 1. You could have chosen either of the other ones and you would have got the exact same answer. So any pair of sides are going to be equal to each other. So we're going to move my variables to the left. Move my constants to the right. I'm going to get 2y is equal to 24, which means that y is equal to 12. So there you go. X is equal to 9. Y is equal to 12. And that is the end of the notes. All right, y'all are going to be working on homework now after this. If you got any questions, I'll be back on Monday. I will see you then in class.